In this video, we'll learn about the refraction section of the VrayMtl. For this scene, we got this bottle and glass geometries. Later on, we'll use these gem objects as well. I also have a shader ball in this scene, which we might not use it in this lesson, but it would be useful later on. So let's open up the material editor by pressing M. Create a new VrayMtl. And assign it to the bottle and the glass for now, and open up VFB and run IPR. Most of the refractive and transmissive materials don't have a diffuse component or have a very dark diffuse color. So let's zero out the diffuse color completely. Also, if you take a look at a piece of glass, you would notice very strong reflection. So let's use a reflection color with a value of 250 maybe. Now we are ready to start working on the refraction section. So first we have refraction color, which controls the color and the amount of the refraction contribution. When set to black, we don't get any refraction, and when set to brighter values, we start to get refraction and add transmissive properties to our shader. Sometimes you need to refresh the IPR session to get the shader look correct. At 0 or pure black, you have no refraction, and as I increase the color value and use brighter colors towards white, we start adding more and more refractive or transmissive quality to the surface. And at pure white, we get a fully refractive shader. Now we can use any other color to get a fake colored glass if we want it. We can use green, blue, or any other color that we want here as well. For now, let's use a pale blue color with the RGB values of 230, 246, and 255. And this will result in a uniform sort of fake coloration of the refraction component of the shader. There is a better way to get colored glass that considers the shape and thickness of the geometry using the fog color and depth parameters down here. We get back to that in a moment. For now, let's use a pure white color. To control how sharp or rough the surface is, you can use the refraction glossiness value. At 1, we get sharp refractions, and as I decrease the glossiness, we get more blurry refractions, which results in a frosty glass look. You notice even though we get a frosty glass shader, but the reflections are still very sharp, and that might not be desirable, as in reality a frosty glass in most cases would have rougher reflections as well. So we can come up to the reflection section and decrease the glossiness there to 0.8 as well. Now we get a more realistic frosty glass shader. For now, let's set reflection and refraction glossiness to 1. Like other parameters, we can control refraction glossiness with maps. In this case, let's load floral01.png as the refraction glossiness map. This map is pure black and pure white. There is no in-between gray values. So where it's white, we get glossiness of 1, and where it's black, the glossiness would be 0. I don't want that. So let's select the map and go to its output rollout. Enable color map, and let's first invert the map completely because I want the flowers to be darker and appear blurrier on the surface of the geometry. Okay. And now the right point controls the darker parts of the map. So let's increase it to 0.7 so they become a bit brighter and therefore cause less blurriness on the surface. Let me quickly hide the floor geometry as it is mostly white and hard to see the effect. I know these geometries don't have proper UVs. If I go to the isolate selected mode and select the map in the editor, you notice it's not being applied correctly. So let's run it through a triplanar node. So I'm going to add one from the Vray maps and use the floral texture as its texture input. And use the triplanar map as the refraction glossiness map. I'm going to increase the triplanar size to 35 centimeter and set frame offset to 30 centimeters just to hide the sims a bit. I'll be using the same map for the reflection glossiness as well, and now we start to see this floral texture controlling the reflection and refraction glossiness values. Now let me stop the render for now and show you a saved render in the history panel. Cool. For now, let's unhide the floor and set the reflection and refraction glossiness to 1 and run the IPR again. The next important parameter for refractive materials is IR, or index of refraction. In the previous lesson, we talked about IR and how it both controls Fresnel reflectivity and index of refraction. So when the material is only reflective, it only controls the Fresnel reflectivity, but when the material is both reflective and refractive, the IR value controls both Fresnel reflectivity and index of refraction. So IR here controls how much light rays will bend as they enter a medium. This value is 1 for vacuum, so the light won't bend in vacuum, 1.33 for water, 1.5 for household glasses, 2.4 for diamond. So that means the speed of light won't change in vacuum. For water, it means light rays travel 1.33 times faster in vacuum compared to water, and so on. So the higher the value, the more bending will occur for the light rays. You can find IR values for different transmissive materials on the internet. As we are dealing with glass, let's go for 1.5 or 1.52, which is more accurate. The next parameter I want to talk about is this dispersion AB number. To see how this works, let's hide the glass and the bottle and unhide the gem's geometry and assign our shaders to them. Dispersion AB controls how much the index of refraction varies across wavelength. By default, it is turned off, so let's enable it. Now, the lower the value, the more dispersion the shader would have. Normally, you would use a value between 10 to 70 to stay in the normal ranges. Let's try 1. Very strong dispersion. Let's try 5, 10. As we start increasing the AB number, the dispersion will become weaker. And if I set it to something like 70, or the highest value you can use here, which is 150, the effect would be very minimal. The normal range is between 10 to 70. For diamond, you can use something like 55. For sapphire, around 72. So it's really up to you. We can disable dispersion altogether for now and hide the gems and unhide the bottle and the glass. To achieve realistic colored glass materials, we need to consider two parameters down here in the translucency section: fog color and depth. Obviously, we'll learn about the translucency section later on. For now, let's focus on fog color and depth values. Now, if you use fog color to achieve colored glass, it takes into consideration the thickness of the mesh. It basically controls the color of the light as it passes through a transmissive or refractive surface or mesh. Now, fog color filters the refraction according to the distance traveled by the refracted ray. The longer light travels inside a mesh, the more it is affected by the fog color, meaning the white light ray will turn into the defined fog color. Therefore, for example, green glass gets a deeper green as rays travel through thicker parts. Now let's change the fog color to a light blue color, for example. I'm going to set the red to 184, green to 237, and blue to 245. And as you can see now, we have blue glass, but in the thinner parts of the object, we have a less saturated version of that blue color. And in the thicker parts, we are getting more saturated, darker shade of that same color. So the color changes based on the thickness of the mesh. And naturally colored glass has different shades of a color based on its thickness. Thinner parts will be tinted lighter and thicker parts will have darker shades of that color. Now, Depth here controls the depth into the volume at which the fog color is realized. Increasing this value makes the volume thinner, which means less absorption and scattering. It's a scale factor so that you can set a fog color and then tweak the depth to be appropriate for the size of your object and control how the fog color affects the thick and thin parts of your object. So if we set the depth to something like 0.2, which is quite low, we get a much thicker, more opaque, more saturated shade of blues. And as we start to increase the depth value to 1, 2, 3, 5, and 10 centimeters, now, because the refracted rays need to travel much farther through the object before becoming this defined blue of the fog color, therefore that blue color would be less and less visible as we increase the depth value. For now, let's use white as the fog color and set the fog depth to 1 centimeter, which is the default value. Now we get these transparent realistic shadows because this effect shadows is enabled. When disabled, we get this dark unrealistic shadows. Maybe it can be useful for compositing purposes in post, but you normally want to have it enabled to get this beautiful transparent shadows. Now this effect channels specifies which channel will be affected by the refraction portion of the material. If set to color only, refraction affects only the RGB channel and not alpha. If set to color plus alpha, it will affect both RGB and alpha channels. And if set to all channels, it will affect all the eligible render elements. Next, we have max depth, which is the number of times a ray can be refracted at lower values like 1 or 2. As we don't allow the refraction rays to be refracted enough times, we get inaccurate results. The default value of 8 should be more than enough for most cases. So in this lesson, we learned about the refraction section of the VrayMtl. See you in the next video.